We are team AAA for the Arduino contest project. We are from San Jose State, Mechanical Engineering Department. My name is Andrew He. I'm a freshman in Mechanical Engineering.
Hello, my name is Andres Cuenca. I am a transfer student at San Jose State. I'm majoring in mechanical engineering. And my role for this project was working closely with the Arduino, providing some assistance in programming and innovating ideas for the design.
Hello, my name is Jan Andrew Donato. I am a transfer student at San Jose State University, and my role for the project was building the water dropper and seed dropper for our farming.
So we wish our robot would enter the space scene for the project for the competition, because in the near future, in 5 years, 10 years, we probably would go to Mars and colonize it. At that time, robot will be really impressive and automated. That we shouldn't be doing the farming and architecture by ourselves. A robot should do all of it.
This rover is called Turtex. They got the inspiration just because it looks like a turtle. So the mounting bracket gives it the head shape. And the mounting bracket is perfectly used to hold the ultrasonic sensor. And then it has like this sort of like hump shape. So it kind of looks kind of like a shell. So let me start off by mentioning about the drill. So what we did is we used I worked on SolidWorks to design this drill. And we were able to 3D print it at one of the community colleges. And here, what we're using is an Arduino Uno. This is a microcontroller used to control the rover. And at the same time, mounted on top of this Arduino Uno is a motor shield. This is used for controlling 4 DC motors. One of them is in the back, while the other one is in the front. So it provides that navigation for the rover. The 2 DC motors here is one to be used to drive up and down the drill, while the other one is to drive down the
kind of putting together this sensoring system and coding for all the motors, including the navigation 2 motors and the motor for the soil sensor and the drill bit. So for the sensoring system, we have an Arduino Pro Micro, a GPS sensor, a DHT11 temperature and humidity sensor, and a soil humidity sensor. And it's connecting to my phone through a HCC6 slave Bluetooth module. So basically how it works is it has virtual pins and receiving data and directly displaying it on my phone. Let's plug this in here. And you can see the Bluetooth module is blinking. And once I start, and once it's connected, and the Bluetooth module will stop, blink, and I will get all the data and also the GPS. It's working. You can see the precise latitude and longitude here. That's the map. That's the humidity sensor, air. That's the temperature. It's 18 degrees C right now. And that's the soil humidity sensor. It's kind of working, even in water, which we can see the numbers changing. So that right now it's 900.
For Turtex is that we want to enter our project into the Thales Arduino space segment. What we hope for our project is that we want it to be used in Mars as an automative farming rover. One of the key components that I was responsible for making was the seeder dropper and the water dropper. A lot of the components that I have made for The seeder and water dropper were entirely DIY except for the servo. The servo is responsible for controlling both the flow of the seeds and the water that falls down through the pipes, which would be carried out onto the bottom of the terrain. For powering our rover and its components, we have several battery packs. This one's 5 volts, this one's 6 volts, and this one's 9 volts. The 9-volt battery pack is responsible for controlling the entire rover's movements, and the 5 volts is responsible for the servos, and the 6 volt is responsible for controlling the servo.
Something we have learned is that if there is some problems, just don't give up and somehow it will work out. And for the motor shield, is that power management is really important. We could have used a more powerful battery pack. And we'll give to Andreas.
So one of the improvements for the next phase of the rover would be 3D printing our own chassis and providing much more bigger space for the rover.
And for designs for the components, I hope to at least create 3D print the seeder and the water dropper. At the same time, have a overall shell for the rover's components. That way they're much more intact and safe as it moves and navigates through the terrain.
We could also have more ultrasonic sensors, and then we actually bought a Arduino camera, but we forgot to bring it. That would be a very special feature.